In this question बच्चों, first of all let's forget about these names A, B and C. Okay, forget about these names. I will name them on my own. So let's give this point name as B and let's name this point A. So this point will also be A बच्चों, this point will also be A. This point will also be A and this point will also be A because all of them are directly connected to point A. So this plate will also be called A and this plate will also be called A and this plate will be called B. Now if we redraw the circuit my dear bachcho with A and B on one side, you will realize that there is a battery between A and B with the positive terminal connected to A. Very good. Also at the same time there is a capacitor C between A and B. So I will draw a capacitor C between A and B. And there is another capacitor C also between A and B. So I will draw one more capacitor with C between A and B. Now my dear bachcha log, what will be the total energy stored in both of these capacitors? That will just be half into C equivalent into V square. That will be half into 2C into 12 square. That will be half into 2 into A epsilon naught by D. So area my dear bachcha log is 50 centimeter square. Epsilon naught is 8.85 into 10 power minus 12. A epsilon naught divided by D. D is 3 mm. Multiplied by 12 square. Now my dear bachcho, when you do this calculation, you will get the answer 2.1 into 10 raised to the power minus 9 joules. So option B will be the correct answer. Please do the calculation on your own bachcho. Do not make me do the calculation. This question my dear bachcha log is very similar. It's not very similar, it's actually same as question number 60 of the first exercise, and you can find question number 60 of the first exercise when you click on the link here. Please click on it my dear bachcho to find that question. In this question my dear bachcha log, 80 microcoulomb is given to the upper plate of the 4 microfarad capacitor. Then in steady state we have to calculate the charge on the upper plate of 3 microfarad capacitor. So my dear bachcha log, what I will essentially say is that there is a charge 80 microcoulomb that was sent down like this. Now that charge obviously bachcho will be divided into two parts. Let's call them Q2 and Q3. Now because of that charge there will be potential differences here and here. Now since 2 microfarad and 3 microfarad are connected in parallel, what I can say is that potential difference across both of them will be same. Now Q is equal to CV, so V is equal to Q by C. So what I will say is potential difference across the 2 microfarad capacitor is the same as the potential difference across the 3 microfarad capacitor. Also at the same time my dear bachcho, Q2 plus Q3 is equal to 80 microcoulombs. Now beta, if you see we have a system of simultaneous equations. If you solve them beta, you will get the correct answer. For example, from the first equation I will get Q2 is equal to 2Q3 by 3. Substitute that value here, you will get 2Q3 by 3 plus Q3 is equal to 80 microcoulomb. That gives me 5Q3 by 3 is equal to 80 microcoulomb. That gives me Q3 is equal to 48 microcoulomb. So my dear bachcha log, the charge on the upper plate will be plus 48 microcoulomb, charge on the lower plate will be minus 48 microcoulomb. So the answer will be option C. In this question my dear bachcha log, we have to calculate the total energy stored in the condenser system. Now, in order to do that, beta, let us just calculate the equivalent capacitance. These two capacitors are in series. What will be their equivalent capacitance? I will write down 1 by 3 plus 1 by 6 is equal to, if you do the calculation, that will become 3 by 6, that will just be 1 by 2. So overall, both of them, my dear bacha log, will just become 2 microfarad capacitors. So in this case, the equivalent capacitance will just be 2 plus 2, that is 4 microfarads. Now, what will be the total energy stored? The total energy stored will be half into C equivalent into V square. That will be half into 4 microfarad into 2 volt the whole square. That beta, when you do the calculation, will be 8 microjoules. Option C will be the correct answer. I hope everybody understood. In this question, my dear bacha, look, we have to calculate the ratio of charges on C2 and C4. So, my dear bacho, what I will first do is I will draw, I will calculate the equivalent of this C1, C2 and C3. Okay, what will be the equivalent? Let's call that C dash. So I will write down C dash will just be 1 by C1, which is C, plus 1 by C2 plus 1 by C3. Now when you do this calculation, it will be 3 plus 2 plus, it will be 6 plus 3 plus 2 divided by 6, that is equal to 11 by 6. So equivalent of those three capacitors will be 6 by 11 microfarads. Okay, so if I redraw the circuit, my dear bacha, look, this is what it will look like. There will be C4 like this. C4 is nothing but 4C, and in parallel you will have a 6 by 11 microfarads. Sorry, not 6 by 11 microfarads, 6 by 11 C. Where did I forget C? C. So 6C by 11. Now, my dear bacha log, if I talk about the charges, there will be charge plus and minus Q1 here, and there will be charges plus and minus Q2 here. Now Q1 will be equal to 6C by 11 into V, and Q2 will be equal to 4C into V. If I take the ratio of Q1 by Q2, my dear bacha log, that will just be 6C by 11V upon 4CV. That will just be 3 by 22. Now understand, my dear bacha log, that here also charge will be Q1, and here charge will be Q1, Q1 and Q1. So charge on C2 divided by charge on C4 will just be Q1 by Q2, which will be 3 by 22. Option B will be the correct answer. In this circuit, my dear bacha log, we are supposed to calculate the total charge deposited on the 4 microfarad capacitor in the circuit. Now in order to calculate that, my dear bacho, first of all we will try to simplify the circuit. If you see, this 4 and 2 are in parallel, so I can simplify this to a 6 microfarad capacitor. Now this 6 microfarad and 6 microfarad are in series, so I can simplify that to a 3 microfarad capacitor, because in series 1 by 6 plus 1 by 6 will just be 2 by 6, which is 1 by 3. So their series will just be 3 microfarad capacitor. Now if you see in this case, my dear bacha log, there will be some charge coming out of the battery Q, that charge will be deposited on the equivalent capacitor. I can calculate that charge with that will be equal to C equivalent into V, that will be equal to 3 into 12, that will be 36 microcoulombs. So 36 microcoulomb, my dear bacha log, will come out from here. That means 36 microcoulomb will come out of here as well, and that means 36 microcoulomb will come out of here as well. Now that 36 microcoulomb, my dear bacha log, will get divided into Q4 and Q2 here. Now since 4 microcoulomb and 2 microcoulomb are connected in parallel, what I can say is, my dear bacha log, that their potential difference will be same. Now Q is equal to CV, V is equal to Q by C. So potential difference across the 4 microfarad capacitor will be same as potential difference across the 2 microfarad capacitor, which gives me Q2 is equal to Q4 divided by 2. Also at the same time, my dear bacho, the total charge will be same as the total charge will be same as 36 microcoulomb. So I will just write down Q2 plus Q4 as equal to 36 microcoulomb. Substitute the value Q4 by 2 plus Q4 is equal to 36, which gives me Q4 is equal to 24 microcoulomb. Now 24 microcoulomb beta is option C, so that would be the correct answer. In this question, two capacitors C1 and C2 are joined as shown in the figure. The potential at point A is V1 and the potential at point B is V2. We have to find the potential at point C. Now, my dear bacha log, if I have V1 potential here and V2 potential here, what will be the potential at the midpoint? So first of all, what I will say is beta, that let's say charge Q flows in this direction. That means there will be plus minus Q charge here and there will be plus minus Q charge here as well. Now if the potential at this middle point is equal to X, and for a minute you forget about this, for a minute my dear bacha log, you forget about the capacitor C2 and only look at capacitor C1, what you can say is, my dear bacha log, that Q is equal to C1 into potential difference. What will be the potential difference across C1 beta? It will be V1 minus X. Remember, charge flows from a higher potential to lower potential. Now similarly, if you look only at capacitor C2, you can say that charge on the capacitor C2 will just be C into potential difference. This will be X minus V2. Now, my dear bacha log, if you just equate the two equation, that would just give you the final answer. Remember, my dear bacho, that charge always goes from higher potential to lower potential. If I have 12 volt and 4 volt, that means charge will flow in this direction. This will be positive, this will be negative. If I had something like this, charge will always go from higher potential to lower potential. Then charge would go in this direction. This will be positive, this will be negative. Okay, all right. Now if you just solve this equation beta, you will get, what will you even get? C1 V1 minus C1 X is equal to C2 X minus C2 V2, which gives me C1 plus C2 into X is equal to C1 V1 plus C2 V2, which gives me X is equal to C1 V1 plus C2 V2 upon C1 plus C2. If you see, my dear bacha log, that is option A, the correct answer. I hope everybody understood. है ना? In this question, my dear bacha log, 4 capacitors are connected as shown in the figure. We have to find the potential difference across the 4 microfarad capacitor. So bacho, first we will try to simplify the circuit. This can just be made as a 300 volt battery in connection with a 20 microfarad capacitor in connection with a 8 microfarad capacitor in connection with the 12 microfarad capacitor. 4 and 4 in parallel beta will become 8. Now in this case beta, I can calculate the equivalent capacitance. 1 by C equivalent will be 1 by 20 plus 1 by 8 plus 1 by 12. If you see, the LCM of all of them will be 120. So it will be 6 divided by 120 plus 15 divided by 120. 15 into 8 is 120. Yes, correct. Plus 10 divided by 120. That will just give me 6 plus 15 is 16 plus 15 is 31 by 120. So C equivalent, my dear bacha log, will just be 120 by 31. Now that gives me, my dear bacha log, the charge that comes out. If let's say charge coming out of the battery is Q, then the charge here will be plus minus Q, the charge here will be plus minus Q, and the charge here will also be plus minus Q. And that Q, my dear bacha log, will be C equivalent into V. That will be 120 into 300 divided by 31. Now that charge, my dear bacha log, that charge Q that came out of the battery will divide half and half into both the capacitors here, because they are in parallel and they have the same capacitance. So charge on the 4 microfarad capacitor will just be 60 into 300 divided by 31. That, my dear bacha log, if you do, will be somewhere around let me use the calculator, है ना? 60 into 300 divided by 31. Yes, it will be somewhere around 580 microcoulombs. So my dear bacho, the option D will be the only one that matches. Option D will be the correct answer. Next is this question. We have to calculate in this circuit, we have to calculate the energy stored between in the capacitor connected between the points A and B. We have to calculate the energy stored in that capacitor, my dear bacho. Now in order to do that, my dear bacha log, we will have to redraw this circuit. It's going to be difficult, but we will do that beta. Okay, first of all, understand, my dear bacha log, that here this point will also be A, this point will also be A, this point will be B, this point will also be B, this point will also be B. Now this point can be neither A, B, or neither A nor B, so we will call it point T. This point will also be T. Now when I redraw the circuit, my dear bacha log, what I will say is that the 10 volt battery is connected between A and B like this. And there is a capacitor, this capacitor C is also joined between A and B directly. There are other capacitors as well. These and these are also there. There is a point D here, my dear bacha log, and there is a capacitor C between A and D, and there is a capacitor between B and D, of course. And there are 2 capacitors actually between B and D. Okay, but we are supposed to look at that capacitor, my dear bacha log, the capacitor which is talked about in the question. If you look at this capacitor beta, the potential difference across that capacitor will just be 10 volts because it is directly connected parallel to the battery. It's directly connected to the point A and B. So what I can say is that energy stored in that capacitor will be half into C into V square. And for that capacitor, capacitance is given as 1 microfarad and the potential difference is given as 10 volts. So that will just become 50 microjoules. So option A will be the correct answer. If you guys still don't understand beta, let us start marking the potentials. If you mark the potential at one point as 0 and one point as 10, what you will realize is that all the points which I have written as A will have potential of 10 and all the points which I have written as B will have a potential of 0. So potential difference across this capacitor will be 10 volts. For that capacitor, the energy stored will be half CV square. In this next question, my dear bacha log, we have to talk about the value of capacitance based on the potential difference. So here bacho, what you should understand is that this will be the potential difference across the first capacitor V1 and this will be the potential difference across the second capacitor V2. Okay, V2. Now, since both the capacitors are connected in series, by the way, sorry, plus minus are opposite here, my mistake. One second, let me just remove that. Plus minuses are opposite here. Sorry for that, bacho. Minus and plus, minus and plus, V2. And this will be that V2 potential difference. Now, my dear bacha log, here because they are connected in series, their charges will be same and their potential differences V1 will be Q by C1 and V2 will be Q by C2. Now, if you clearly see from the graph, from the graph. Now, it's not very clear, my dear bacha log, but it's kind of clear. From the graph, we can see that V1 is less than V2. So essentially Q by C1 is less than Q by C2. If I do the cross multiplication, Q will get cancelled out and for the remaining I will do cross multiplication. I will get C2 is less than C1, or what I can say is C1 is greater than C2. So my dear bacha log, option C will be the correct answer for this question. In this question, my dear bacha log, we have to calculate the charge on the charge in microcoulomb on the charge in microcoulomb for the 5 microfarad capacitor. Okay, so in order to solve this question beta, we will start making this. We will start simplifying this circuit. This 2 and 5 are in parallel, so we will make them a single capacitor of a 7 microfarad capacity. Step by step, let us simplify this. This is 4 microfarad beta and this is 6 volts. Now beta, this 7 and 3 are in series. We can simplify that further beta and that will become 21 by 10, so 2.1 microfarads. And 4 microfarads. My god, I am running out of space to write. Let me just write somewhere else. One second now. Let me just write it somewhere here. Let me just first make this smaller. That battery is too big. It doesn't have right to be so big. Yes, 6 volts. So what I can do is simplify this circuit a little bit. That 7 and 3, my dear bacha log, will become 2.1 microfarads This 4 microfarads will just remain 4 microfarads, and it will be connected, my dear bacha log, to this. It will be connected to 6 volt battery. Now bacho, here since both the capacitors are connected in parallel to the battery, both of them will have different charges, Q1 and Q2, but both of them will have the same potential difference, which is 6 volts. So Q1, my dear bacha log, will just be equal to C1 into V. That will be nothing but 2.1 into 6. That is nothing but 12.6 microcoulombs. So my dear bacha log, what is happening is that there is a charge of 12.6 microcoulomb that is going from here to here, which means, my dear bacha log, that there is a charge of 12.6 microcoulomb that is traveling here, and if I go back to the original circuit, there will be a charge of 12.6 microcoulomb which will be traveling here. Now that 12.6 microcoulomb, my dear bacha log, will get further divided into Q2 and Q5. Now about Q2 and Q5, my dear bacha log, what I can say is, because 2 and 5 microfarads are in parallel, they will have the same potential difference. The potential difference Q2 by C2, Q2 by 2 microfarads will be same as the potential difference Q5 by 5 microfarads, which gives me beta Q2 is equal to 2 by 5 Q5, or I will just write it as 0.4 Q5. Also at the same time, my dear bacha log, Q2 plus Q5, the total sum beta should be 12.6 microcoulombs. So 0.4 Q5 plus Q5 is equal to 12.6, which gives me Q5 is equal to 12.6 divided by 1.4. Now my dear bacha log, 14 into 9 is 126. So 12.6 by 1.4 will just be 9 microcoulombs. So option C will be the correct answer. The charge going to the 5 microfarad capacitor will be 9 microcoulombs. I hope you guys understood. Next, my dear bacha log, is this question. In this question, there are 4 capacitors, each having capacity of 25 microcoulomb, and they are connected as shown in the figure. The DC voltmeter reads 200 volts. We have to calculate charge on each plate of capacitor. Now, my dear bacha log, what you have to understand here is that if the voltmeter reads 200 volts, that means one side of the voltmeter will have a potential of 200 volts, and other side of the potential voltmeter beta will have a potential of 0 volts, so that the difference is 200. Now beta, if that is 200 and 0, we can mark other points also as 0 and 200, which I will mark here, and we can mark other points as 200, which I will mark here. Now as you can see, potential difference across each capacitor is also 200 volts if you mark the potential at all points. Now if you just look at this capacitor, my dear bacha log, what you will realize is that charge on this capacitor will just be C into V. Now capacitance beta is 25 microfarads, and the potential difference is 200 minus 0. That will be beta 25 into 200, 25 into 2 is 50, that will be 5000 into 10 power minus 6, or 5 into 10 power minus 3 coulomb. So option B will be the correct answer. In this question, my dear bacha log, there are a number of capacitors, each having capacity 1 microfarad, and each one of them are getting punctured. If a potential difference just exceeding 500 volts is applied, each of them will get punctured if a potential difference more than 500 volts is applied. An arrangement suitable for giving a 2 microfarad capacitor across which 3000 volt may be applied requires at least this many capacitors. Now beta, this question is very similar to question number 60. This is similar to question number 60, which I have already solved, and you can find its link above here. You can find its link above and the right top corner. But no worries beta, let me solve this question one more time. Now here, my dear bachcha log, here my dear bachcha log, first of all understand that I can't connect to 1 microfarad capacitor like this, 1 microfarad and 1 microfarad in parallel to create the arrangement, because if I create this arrangement beta, this will not work. Even though its equivalent capacitance is 2 microfarad, but it will not be able to handle 3000 volts of a potential difference. If I connect it to a 3000 volt battery, then beta, both the capacitors will get punctured and both of them will start conducting electricity, because both of them can only handle 500 volts. So what I need to do is beta, first I need to create an arrangement of these capacitors so that they are able to handle 3000 volts. Now my dear bachcha log, in order to create that arrangement, I will have to arrange the capacitors in series, because when we connect capacitors in series, my dear bachcha log, they will divide voltage. Essentially, my dear bachcha log, what I will do is I will create a combination of 6 capacitors in series. 6 capacitors in series, because if I connect all of them in series to the 3000 volt battery, my dear bachcha log, then what will happen is that this 3000 volt will divide into each of them, and each of them will only get a potential difference of 500 volts. Each of them will only get a potential difference of 500 volts, because 3000 divided by 6 is 500. Now the problem is beta, that if I create a combination of 6 capacitors in series like this, then the equivalent capacitance of this circuit will not be 2 microfarad. Here the equivalent capacitance of this circuit will only be 1 by 6 microfarad. Now I don't need 1 by 6 microfarads beta. I need 2 microfarads overall. So what I will do beta is, now I will use this and connect, I will use this series connection and just connect copies of it in parallel. Essentially beta, what I will do is I will connect 6 capacitors in series. Okay, I have 6 capacitors in series. What I will do is I will make 12 rows of that. How many rows I will make, my dear bachcha log? 12 rows. Because when I make 12 rows of that, my dear bachcha log, when I make 12 rows of that, like this, then beta, on connecting a 3000 volt battery, first of all the capacitors will get a potential difference of 500 volts, of course. And my dear bacha log, the C equivalent in this case will be the equivalent capacitance of one row multiplied by 12, that will be 2 microfarads. So this combination beta will work as a combination of having equivalent capacitance of 2 microfarads and being able to handle 3000 volt potential difference. And in this case, my dear bacha log, we need how many capacitors? If we talk about a number of capacitors here, that will be equal to 6 capacitors in one row and 12 rows in total. We need 72 capacitors. Understand beta, why are we doing all of this? We are connecting the 6 capacitors in series to divide this voltage. That is the purpose. Connecting the 6 capacitors in series will divide the voltage. And then we are connecting 12 rows of these series capacitors to get an equivalent capacitance of 2 microfarad. So when we do both these things beta, we will get a voltage of 500 volt on each capacitor plus an equivalent capacitance of 2 microfarads. So option C will be the correct answer here. Bacha log, in this question there is a capacitor of capacitance 20 microfarads. Okay, which is charged up to a potential of 500 volts. And it is connected in parallel with another capacitor of capacitance 10 microfarads. Which is charged up to 200 volts. We have to, when they are connected in parallel, when this switch is closed, my dear bacha log, we have to calculate the common potential. So first, my dear bacha log, we will calculate their original charges. So original charges will be, I can calculate Q1. I can calculate the charge on the 20 microfarad capacitor. That will be equal to nothing but 20 into 500, that will be equal to 10,000 microcoulombs. 10,000 microcoulombs. Wow, correct. That is 0.01 coulomb. Let's just call it 10 power minus 2 coulomb. Okay, and so I will just write on 10 power minus 2 coulomb. Okay, now my dear bacha log, what will be the charge on the second capacitor? So I will write down that Q2 will be equal to CV 10 into 200. Remember, I'm using the formula Q is equal to CV. So that will just be beta equal to 2000 microcoulombs. So I'll just write down 0.2 into 10 power minus 2 coulomb. You know what? Let me just write this down. This is just very weird. The units values are very weird. Chalo, let me just write this down as 10,000 microcoulomb can just be written as 10 into 10 power 10 into 10 power minus 3 coulomb, or 10 millicoulomb. Yeah, that is much better. And this can just be written as 2 into 10 power minus 3 coulomb, or 2 millicoulomb. Oh, this is so much better. Very nice, very nice. So let me just write it as 2 millicoulomb and 10 millicoulomb. Okay, now in this case beta, when I close the switch, what happens is that some charge will go from higher potential to lower potential. Let's say charge X goes from higher potential to lower potential. Then beta, the new charge on the 20 microfarad capacitor will be 10 minus X, and the new charge on the 10 microfarad capacitor will be 2 plus X. Okay, now when they are connected in parallel beta, their potential will remain the same. So what I will say is that 10 millicoulomb minus X divided by 20 should be equal to 2 millicoulomb plus X divided by 10. Now if you cross multiply beta, I will get 10 millicoulomb minus X is equal to 4 millicoulomb plus 2X. This gives me 3X is equal to 6 millicoulomb. X is equal to 2 millicoulomb. Now my dear bachcha log, I have to calculate the common potential. I have to calculate the common potential. That common potential, my dear bachcha log, you can just calculate potential of any capacitor. I will just calculate potential of 20 microfarad capacitor. It will be the new charge. It will be the new charge divided by the capacitance. Now substituting the values beta, it will be equal to 8 millicoulomb divided by 20 microfarad. That will be equal to beta 8 into 10 power minus 3 upon 20 into 10 power minus 6. That will be 4 by 10, 400 volts. So option C will be the correct answer. Nice and simple. Next, my dear bachcha log, is this question. Here initially there is a capacitor which has a charge, which has energy U. So let's say this capacitor has charges plus and minus Q and capacitance C. Its energy beta will be Q square by 2C. Now it is connected to another identical capacitor. When it is connected to another identical capacitor which is uncharged, what happens is, my dear bachcha, when the switch is closed, what will happen is that the charge will get redistributed, and since they are identical capacitor, both of them will now have half the original charge because the charge will get distributed. Now here the new energy of any one capacitor will just be equal to Q by 2 the whole square divided by 2C. That will be 1 by 4 into Q square by 2C. That will be nothing but U divided by 4. So option D will be the correct answer. Here a condenser having capacity 2 microfarad is charged to 200 volt potential. Its plate are joined to a resistance wire. Find the heat produced. Here beta, the energy stored in the capacitor will be half into C into V square. That will be half into 2 into 10 power minus 6 into 200 the whole square. That, my dear bachcha log, will just be 4 into 10 power minus 2 joules. Now when beta this capacitor is connected to a resistance wire, the heat produced will be same as the original energy stored in the capacitor. So answer here will be option C, that is 4 into 10 power minus 2 joules. Next is this question. 3 capacitors each of capacitance C and breakdown voltage V are joined in series. The capacitance and the breakdown voltage of the combination will be what? Beta, in this case I have one capacitor 2 capacitor and 3 capacitor are joined in series, C, C and C. Each of their breakdown voltage is V, V and V. In order to break all of them down beta, I will have to give them an overall voltage of 3V. The sum of V will be 3V. So overall breakdown voltage for the series combination will be 3V, and the overall equivalent capacitance will be given by the formula 1 by C equivalent is equal to 1 by C plus 1 by C plus 1 by C, which gives me C equivalent is equal to C by 3. So option C will be the correct answer. I hope everybody understood. In this question beta, a potential energy of a charged parallel plate capacity connected to a battery is U. So beta, there is a capacitor connected to a battery. Its potential energy is U naught. What will be U naught beta? It will be half CV square. Now there is a slab of dielectric constant K inserted in between the plates. So beta, in that case the new capacitance will just become K times C. And now you have to calculate the new potential energy stored. Now in this case beta, remember that whenever a battery is connected and we insert a dielectric slab, then the potential remains constant and the charge changes. In this case the potential remains constant, charge changes. So beta, what will be the new potential energy? The new potential energy beta will be half into C dash into V square. That will be half K C V square. That can just be written as K times half CV square. That will just be K times U naught. So option B will be the correct answer. I hope so, but everybody understood. Next is this question beta. A parallel plate capacitor is constructed using 3 different dielectric materials as shown in the figure. The parallel plates across which the potential difference is applied has area A meter square and is separated by a distance D meter. Find the capacitance across AB. So here my dear bacha log, what we will do is we will think of a circuit like this. What will we think of beta? One capacitor C1 like this, and on the other side 2 capacitors C2 and C3 like this. Okay, now here what will be C1? It will be K1 into A by 2 epsilon naught by D. That will be K1 by 2 A epsilon naught by D. What will be C2? That will be K2 A by 2 epsilon naught upon D by 2. That will just be K2 A epsilon naught by D. And similarly C3 my dear bacha log will be K3 A epsilon naught by D. Now what I will do, I hope you guys understood how I made this circuit diagram. Okay, here K2 K3 will be in series. Now in this case my dear bacha log, I will have to calculate the equivalent capacitance. So what will I do my dear bacha log? I will go to the next slide and I will draw the circuit diagram once again. And let's understand this. C1, C2, C3. Here beta C2 and C3 are in series, so they will just become something like C dash. Where C dash is equal to C2 C3 upon C2 plus C3. If you do the calculation beta, it will come out as K2 K3 upon K1 plus K3, K2 plus K3 multiplied by A epsilon naught by D. You can do the calculation, my dear bacha log. Now your equivalent capacitance beta will just be C1 plus this C dash. So it will be K1 by 2 plus K2 K3 upon K2 plus K3 into A epsilon naught by D. C1, my dear bacha log, is K1 by 2 A epsilon naught by 3, and C dash is K2 K3 upon K2 plus K3 A epsilon naught by D. So beta, overall you will get option A as the correct answer. Very, very good. Next, my dear bacha log, is this question. Next is this question. A system of 3 parallel plates of area A are separated by distances d1 and d2. The space between them is filled with dielectric permittivities epsilon 1 and epsilon 2. The permittivity of free space is epsilon naught. What will be the equivalent capacitance of the system? So beta, essentially I have 3 plates like this. On one side, my dear bacha log, I have dielectric constant epsilon 1. On the other side, I have dielectric constant epsilon 2. The width is d1 and d2. Now, in this case, my dear bacha log, we can think of it as 2 capacitors in series, C1 and C2. What will be C1 by the, my dear bacha log? C1 will be A epsilon 1 by d1. And what will be C2, my dear bacha log? It will be A epsilon 2 by d2. Now how will I calculate the equivalent capacitance? I will say 1 by C equivalent as 1 by C1 plus 1 by C2. That will be d1 upon A epsilon 1 plus d2 upon A epsilon 2. That will be beta A epsilon 1 epsilon 2 common, d1 epsilon 2 plus d2 epsilon 1, which gives me C equivalent as A epsilon 1 epsilon 2 upon d1 epsilon 2 plus d2 epsilon 1. So option D will be the correct answer. In this question, a parallel plate capacitor is filled with a slab of dielectric constant 3, filling the whole space between the plates, and it is charged to a certain potential and then isolated. Then the slab is drawn out and another slab of equal thickness but dielectric constant 2 is introduced between the plates. The ratio of energy stored in the capacitor later to that stored initially is what? So my dear bacha log, initially I have, first of all, it is an isolated capacitor, so it will just have a constant charge, my dear bacha log. Initially it has capacitance C1 as 3A epsilon naught by D, and finally beta, the dielectric is changed to have a constant of 2. So finally the charge will still remain the same, but the capacitance will now become 2A epsilon naught by D. Now in the first case, my dear bacha log, energy will just be Q square by 2 times C1. In the second case, my dear bacha log, energy will be Q square by 2 times C2. Now we have to calculate the ratio of energy stored later to that stored initially. So we have to calculate beta U2 by U1 here. When you do that beta, Q square by 2 gets cancelled out. It will be 1 by C2 upon 1 by C1 that will be left. That will just be C1 by C2. Which, my dear bacha log, when you do, will just be 3A epsilon naught by D upon 2A epsilon naught by D. That will just be 3 by 2. That is option B, the correct answer. In this question, my dear bacha log, 2 capacitors marked 10 microfarad 400 volt and 4 microfarad 100 volt are connected in series. What is the maximum safe potential that can be applied when these capacitors are joined in series? When these capacitors are joined in series, my dear bachcha log, what is the maximum safe potential that can be attained? Now beta, if I connect this 10 microfarad capacitor to 400 volts, the charge on that capacitor will just be 10 into 400, that will be 4000 microcoulombs. And my dear bachcha log, if I connect this 4 microfarad capacitor to 100 volts, the charge on that capacitor will be 4 into 100, 10 microfarad 400, 4 microfarad 100, that will just be 400 microcoulomb. This will be actually 4000 microcoulomb. Yes, so what you can see is, my dear bachcha log, that the first capacitor can have a maximum charge of 4000 microcoulomb stored on it, and the second capacitor, my dear bachcha log, can have a charge of 400 microcoulomb stored on it. Now if you want both the capacitor to be safe, then we will connect them in a series such that both of them does not have more than 400 microcoulomb of charge on it. So that is what I will do. I will connect this 10 microfarad and 4 microfarad capacitor in series, such that, my dear bachcha log, the potential on both of the charge on both of them is 400 microcoulomb and 400 microcoulomb. In that case, my dear bachcha log, what will be the potential? Since they are in series, they should have the same charge, my dear bachcho. Please remember, whenever you connect any two capacitors in series, they should have the same charge. And if I want both of them to be safe, I will go only up until 400 microcoulombs of charge. So in this case beta, the equivalent capacitance will just be equal to 10 into 4 upon 10 plus 4, that will be 40 by 14 microfarads. And my dear bachcha log, the potential will just be Q divided by C equivalent, that will be 400 divided by 40 by 14, that will be equal to 140 volts. So option D will be the correct answer, my dear bachcha. If I keep V is equal to 140 volts, what will happen is that both of them will still be safe. If I increase it more than this 4 microfarad capacitor beta will break down. In this question, a parallel plate air capacitor of capacitance C0 is connected to a cell of EMF V and then disconnected from it. A dielectric slab of dielectric constant K, which can just fill the air gap of capacitor, is now inserted in it. Which of the following is correct? In this question, my dear bachcha, look, there is a capacitor of capacitance C0. It is connected to a battery of EMF V. Okay, now what I am doing is I am inserting a dielectric in that. So the new capacitance will just be K times a C0. Now we have to talk about beta all the different things. Now potential difference between the plates. Now beta here is since here beta, since the question says that the batteries are disconnected, what I will do is I will disconnect it from the battery. I am sorry, I forgot that the batteries were disconnected, did not read that correctly. So when I disconnect the battery, my dear bachcha, look, what you have to remember is that the charge remains the same. Original charge is plus Q minus Q, final charge also plus Q minus Q, because the battery is disconnected. So beta, original energy will be Q square by 2 C0, final energy will be Q square by 2 times K C0. That means beta, final energy becomes the original energy divided by K. So option A will be correct. Oh, sorry. Option B will be correct. Let's also talk about beta potential energy. What will be the potential energy? What will be the potential difference? Original potential difference beta will just be Q by C naught, and the new potential V dash will be equal to beta Q by C dash. That will just be equal to Q by K C naught. That will be V by K. So option A is also correct. Okay, if I ask you beta what is the change in the potential energy, what you will say is that the change in the potential energy will be equal to final potential energy minus the original potential energy. That will be beta Q square by 2 C naught into 1 by K minus 1. Now beta Q square by 2C can also be written as a half CV square. So option D is also correct. So only incorrect option is beta option C. So that would be the answer, because the question is asking which of the following statement is incorrect. Option C will be the correct answer. It's the incorrect statement, so it will be the answer. Assertion: a parallel plate capacitor is connected across battery through a key. A dielectric slab of constant K is introduced in between the plates. The energy which is stored becomes K times. Reason: the surface charge density of charge on the plate remains constant or unchanged. Now in this case, my dear bacha log, the battery is not disconnected, it still remains connected. So originally, my dear bacha log, what you have to remember is, originally you have capacitance C, battery is V, the energy stored is half CV square. Finally beta, because the slab is inserted, finally beta, because the slab is inserted, C dash will be equal to K times C. So the new potential energy will be equal to half into C dash into V square. Remember, in this case potential will remain the same, so that will just become half into Kc into V square. That just gives me the energy as K times U. So assertion is true, the energy stored does become K times. Now beta, they are talking about surface charge density. Let's say the original charge is plus and minus Q, so Q can just be written as CV, and the new charge is Q dash and minus Q dash, my dear bacha log. So the new charge Q dash will just be equal to C dash into V, that will be KCV, that will be K times Q. Now beta, since the charge is changing, the charge density, the surface charge density, which is sigma, will also change. The new sigma beta will be Q dash by A, that will be K times sigma. So reason is definitely false, and therefore option C will be the correct answer. A parallel plate capacitor of capacitance C is charged to a potential difference V. The battery is disconnected and then dielectric slab of constant K is inserted between it. The potential energy decreases. Here beta, since the battery is disconnected, what I will say is that the charge remains constant. Okay, let's say originally the charge is plus and minus Q. Finally, the charge will still be plus and minus Q. The capacitance will become K times. Now the original energy stored will be Q square by 2C. The new energy stored, my dear bacha log, will be Q square by 2C dash. That will be Q square by 2 times Kc. That will be beta U by K. So of course the potential energy decreases. It is true. And here beta, energy stored is given by Q square by 2C is also true. And using that formula only, my dear bacha log, we are proving that the energy stored remains constant. So here what I will say is that both assertion is true and the reason is true, and the reason correctly explains assertion. Option A will be the correct